Hello everybody. Today we are going to be doing circles and we're going to be dealing with the arcs and angles compared to the chords and the lengths of those chords. So we have two different types of problems that we could be dealing with. You could have a circle where the X that you have kind of in the middle of the problem is asking you to find the angle in between, which is not a central angle, it's just near the center, and you could have, let's say, 80 degrees here on that arc from, we'll call it A to B, and we could have 100 degrees here, and that could be the arc from C to D. So if we have this type of problem and we're looking for the angle in the middle, it is actually going to be the average of the 80 and the 100. And a way that you could do it is you could do my formula. I like to say it is 2 times the angle is equal to the outside plus the outside added together. So 2 times the angle equals the out plus the out. And in this case, the outsides are going to be the 100 and the 80. So if we did 2 times the angle equals 80 and 100, the two outside parts, then we would end up with 2 times the angle, or x, is equal to 180. And if you just divide by 2, you're going to get your angle. You're going to get that angle in the middle, which is 90 degrees. Alright? So notice how I said before that really this angle in the middle is just going to be an average of the 80 and the 100, and the number between, perfectly in between 80 and 100 is 90, which makes sense. That angle is 90, and I did an okay job of making it look like a 90-degree angle as well. Okay, so that's when you're looking for the arcs and the angle measurements, but there's a different type of circle problem that won't be dealing with arcs and angle measurements. It's going to be dealing with these two things, which are the chords in the middle, but instead of finding the angle that goes with them, you'll be finding the length, how long is that not diameter, but the chord in between the circles. So we're going to have another X-type problem. Our circles are getting better. We're going to put the X in the middle. Let's do it with orange again. But instead of me looking for this angle in the middle like we did here, we're going to be looking for how big is this side and that side. So we're going to call the middle point C. We're going to have A and B on the side, and we'll call it, R, D here. So let's say that I told you that R to C was 10, not 10 degrees, something like 10 inches, 10 feet. And let's say that we had C to D as 4, it looks a little shorter. And AC, we'll call that, let's call it 8. And I want to find C to B. Okay? So in this case, it's going to be similar to a cross multiplication problem, but it's already going to be set up. We're going to have to take this side from R to C and multiply it with C to D. So we're going to have to do this same side times the same side, or the same chord times the same portion of the chord. So I'm going to call it same times same will equal the same times the same on the other side. Okay, so we're going to have 10 times 4, that would be the same chord times the same chord, would have to equal the same 8 times x on the other side. So we end up with 10 times 4, which is 40. That's simple. And then we have 8 times x on the other side. Well, that's just 8x. So if we end up dividing here, we'll find out really soon that 40 divided by 8 is 5. And that would indicate to us that this part right here in here from C to B, that part would just be 5. Okay? So we're going to do a few other of these problems that we're just going to vary them up a little bit. Not much variant there. Might have a few distributions. And we're going to do that now. So for our next problem, we are just going to make it a little bit more difficult. It's not going to be anything different. It's just going to be a little bit more difficult, which is how we always like to do things. It's always a little bit harder. So for our first problem, I'm not going to tell you which type we're going to have, whether it be looking for the angle measurements or for the chord lengths, because they both look the same. Circle with an X in between. We're going to have, I'm going to say X here. I'm going to say that's 140 degrees there, and I'm going to say that this is 100 degrees here. So given the type of problem that we have to look and determine, are we given angle measurements or arc measurements? And we are. And if that's the case, then we will have to go back to the formula, which is 2 times the angle equals the outsides added together, out plus out. The difference this time is that with our X located here, when we find the average between the 140 and the 100, we're going to get this angle, which is the vertical part of that angle right there. So if we get these parts, then X is not going to be where I have my 2 dots. The X is going to be whatever the 180 minus it, because that's a straight line between X and my dot right now. So we're still going to start it the same way. 2 times the angle equals 100 at the outside plus 140 the other outside. And then we're going to add those together. 2 times the angle equals 100 plus 140 is 240. And then we're going to divide by 2, and we'll find out that that angle is 120 degrees. So if this part right here is 120 degrees, barely squeezed it in there. I'm going to draw an arrow for the other side, 120 degrees for the vertical angle. Then that means that X is not going to be 120 because it's not located in the part that would correlate with the 140 and the 100. It's on like this top part and bottom part, which we don't know what either of those are, but we do know that X, because this is a straight line, is going to have to be whatever 180 minus 120 is. So if we do that, 180 minus 120, you get your 60 degrees. So that means that this part right here, that angle, is 60 degrees. It's nothing different. It just means that you have to be aware of what you're dealing with. So for our next problem, still going to have an X, still going to have a circle, might have a decimal in this one, you never know. Going to label this as well. I'm going to call this A, center as C, B, D, and R. So similar to the last problem, but I think I changed the D and R location, which is do not resuscitate, but not in this case. DC, we are going to call X plus 3, and CR we are going to call just 4. And then I'm going to call A to C a 5, and a C to B a 3. So in this case, it's not looking for the angle measurements. We are going to be dealing with the chord lengths. So we are going to have to recognize that we are going to have to do these insides together will have to equal the insides multiplied together as well. So the formula I gave you last time is same chord times same chord will equal the same chord times the same chord. And I had to label them over here because I just didn't have enough room inside my circle. So if we're looking at D to C, that's x plus 3. And if we look at C to R, that's 4. Well, that would be the same part times the same part. So I could take the x plus 3 and multiply it with 4. So I got 4 times the quantity x plus 3, so I put it in parentheses. And that would have to equal my same side times my same side, which in this case is going to be A to C, which is 5, and C to B, which is 3. So I would have to take my same times my same for the other part, which would be 5 times the 3. And it doesn't really matter which order you put the two same sides in, because when they're multiplied together, it just balances out. So I'm going to have to distribute in this case. Right now, see how there's a 4 in front, I'm going to have to distribute the 4. That's the harder element that we were talking about. We get 4x plus 12. And that would equal 5 times 3, which is 15. We just have to solve this problem. It's going to be a decimal. 4x equals, subtract the 12, 3. And when we divide by 3, you get x is equal to 3 over 4. If we wanted to plug that back in, we could get the length of D to C. We could find the length of D all the way to R. We could do a bunch of things with that. But normally that's about all you have to do. Okay? So, until next time, stay thirsty for knowledge, and I will see you tomorrow.